Alright, so in this video I'm going to be talking about another approach for event extraction, and we are using graph neural network because when we want to leverage dependency parsing, this syntactic information, first we need to create this adjacency matrix. So we model it with graph neural network, and then we train it jointly for event extraction. So I'm gonna be focusing on this paper in 2020. So event extraction is one of the core information extraction tasks whose purpose is to automatically identify and extract information about incidents and their actors from text. So we propose a novel joint event extraction framework that aims to extract multiple event triggers and arguments simultaneously by introducing shortest dependency path in the dependency graph. We do this by eliminating irrelevant words in the sentence, thus capturing long-range dependencies. Also, an attention-based graph convolutional network is proposed to carry syntactically related information along the shortest path between argument candidates that captures and aggregates the latent associations between arguments. So this is an example of event extraction task and its dependency result. The dependency parsing, you can get it with the Stanford Core NLP toolkit, but the dataset for event extraction that here they use is just ACE 25, which is very popular. We propose a novel event extraction based on deep neural net to predict event triggers and their arguments. And then for trigger classification, they focus on solving the ambiguity problem in solving event triggers. For argument identification and role classification, we focus on solving the very long-range dependency problem and the associations between argument candidates. So for very long-range dependency problem between event trigger and argument candidates, we calculate shortest dependency paths. Very good idea, because sometimes the path between a trigger and an argument is too long. The dependency. So for example, here is the event extraction edge, but the dependency is very long, as you see. So it's very good to just find the shortest path. So this is the architecture that first they do trigger classification, then argument identification or role classification. But the input for the kth token of sentence would be a vector with length n sub h. Here is important because they specify the relative distance between a case token of a sentence with trigger candidates. So it's a good feature, and we know this is the PFK is the positional embedding. So shortest dependency path between words we initiated, and then we go through this loop to find the shortest path between tokens of event triggers, and once we have this shortest path, then we can continue. This is an example for preparation of shortest dependency paths, adjacency matrices between argument candidates. And the rest of that is very easy. They just use graph convolutional network. Also, they use self-attention layer. So you see that the font score is 75 for trigger classification, but for argument role classification is 66. So you see state of the art is less than 80%, even in 2024.